Hi there, welcome to my channel. In this video, we are going to solve this particular problem. The problem is climbing stairs. So here we have a staircase and it has n steps and we have to reach to the top. And we can climb either one or two steps at a time. And we have to find out the number of distinct ways which we can climb to the top. So this is the problem and we are given with two examples, one with n2, one with n3. N2 means we have two steps in our staircase. To reach to the top, either we can go here, then here, that is one step, or we can directly move to the second step. So that is another way. So in total, we have two ways for this one. So similarly, we have n3, that means we have three staircase. So here we can go like this, one step at a time. That is one way. The other way is we can go one step, then we can take two steps. That is another way. The third way would be we take two steps, then one step. So in total for this, there is total three ways. So this is how this problem is solved. So let's see a programmatic approach, how we are going to solve this. So let's draw an array first for this particular example. And let's give it 1, 2, 3. And in this array, we are going to store the number of ways to reach to step 1, the number of ways to reach to step 2, and here we are going to store number of steps to reach to step 3. So to reach to step 3, we have to know what are the number of ways to reach to step 2 and step 1. So this depends on these two values. If we have these two values, suppose this is x, this is y, so this value would be x plus y. Similarly, to calculate this value, we have to find this value and this value. And if we add those two, we'll get the y. So here, let's take this example. So we have three staircase, 1, 2, 3. Let's consider we have a 0 here, which will take as 1. So to reach to step 1, we only have one way. We can only take one step to reach to the first step. So now let's calculate for this one, second. So to reach to this one, we have to combine this two value. So if we combine it, we'll get 2 here. Similarly, to reach here, we have to combine this two value. If we add this two, we'll get 3. So this problem kind of looks like a recursive way. So let's try to solve this first. So I'm going to write a simple JavaScript recursive program to solve this first. Then we'll see a optimal way. Let's call it climb stair, and we have an n value. And here, let's get another function. Let's call it count stair with the n value. And here, here we'll write our logic. So here I'll first check if n value is 0 or n is 1. In that case, I'm going to return value 1. As you saw in this array, for 0th and for first stair, we are considering the value as 1. And after this, to calculate the number of ways for this particular stair, we have to know the ways for n minus 1 and for n minus 2. So I wrote a recursive, I'm calling the same function again with a n minus 1 value and n minus 2 value. So this is how we calculate the number of ways for this particular stair. And at the end of the function, we'll just call it. And we'll close it. So this is a recursive function and this will solve this problem. The only thing is the time complexity for this particular function would be 2 of n, which is exponential time complexity, which is very bad. So let's see if we can optimize this particular function. So let's go through this program, how we are solving the problem with this. So let's consider we have an n value as 3. So we'll call this particular function climb stair with a value 3. It will go inside and it will call another two functions with a value n minus 1 and n minus 2. So it will be 2 and this will be 1. Again, this will call another recursive function with a value 1 and a value 0. And if you notice here we are calculating climb stair 1 And here also we are calculating climb stair 1. So this is kind of repeating. So we are doing repeat calculation every time, which is bad. So what we can do, whenever we calculate a value, we store it into some memory location. And next time, whenever we go to calculate the same function again, first we check that particular memory location. If it is already there, then we'll pick it from there. And that technique is called memoization. So we'll combine this recursive function with memoization technique, and that will result into DP, dynamic programming. So dynamic programming is nothing, it's just recursive solution plus memoization technique. So DP can be solved in two ways. It can be either top down or bottom up. So any problem which is solved in top down can be solved in bottom up, and vice versa. So now let's restructure this program by adding memoization to it. So I'm going to rewrite the same function, and here I'm going to add a memory location, and I'll write I'll just copy this one. Okay, let me write it here. I'm rewriting the same function here. The only changes are, instead of calling the function, the recursive function, first I'll check if this value exists in this particular array. If it is there, then I'm going to return it back. Otherwise, I'll check if n value is 0 or 1. In that case, I'll store 1 in my cache value. And if this two condition doesn't met, then I'm going to calculate the value for it, and which will be the recursive function. So here I'm going to pass n minus 1, n minus 2. So here our calculation is done. At the end of this function, we'll return this particular value, we'll close it, and at the end of this function, we'll return it. Yeah, so this is how it is solved in top-down approach. So same program we can write in bottom-up approach. Let's see that as well. So here also the logic will be same. Only thing is, instead of going from top to bottom, we'll be solving our problem from bottom to top. Here also we'll have our cache memory, and in bottom-up approach, we already know that for zero stair, we have one ways, and for first stair, we have one ways. So for the rest of stair, we can just start from second stair, and we can go till the end stair, and here we'll calculate it just like this. At the end, we'll just return our value. So this is how we solve in bottom-up approach. So I've given you 3 solutions. Anyone you can use as per your convenience. And let's talk about the time complexity. So for both of this function, the time complexity is order of n, because we are going through each item of an array only once. And here we are using some extra memory space. So space complexity for this particular function is also order of n. So here I missed one thing. So there will be a else statement here, and other things are fine. So this is how we approach this problem and solve it. So I hope this video was useful to you. Don't forget to like, share, and subscribe, and I'll see you in my next video. Thank you.